So we're going to start today with nitrogen oxides, and there are two in particular. There's nitrogen monoxide, which is a colorless gas and an odorless gas. And there is nitrogen dioxide, which is kind of a brown-orange rust-colored kind of gas that has a very particular strong odor to it. Now, both of these gases have important uses associated with them. Nitrogen monoxide, NO, is a dilator. It'll actually, you give it in small doses inside of a breathing treatment, it can help open up the blood vessels and make the blood and the body a little bit more susceptible to oxygen. Nitrogen dioxide is used in the aerospace industry. It's a primary oxidizer used for the actual combustion of rocket fuels. So what happens is instead of taking up compressed oxygen and compressed hydrogen, which sometimes they do, what is more likely is that they'll take up liquefied substances like nitrogen dioxide and hydroxyzine, nitrogen dioxide and hydrazine, N2H4, and the decomposition products of those two materials are hydrogen and oxygen, which combine together to run the fuel cells. And you've got these components here that also will ignite, that will create basically the propulsion necessary to move the rocket through space. Now, the main issue with both of these has to do with environmental kinds of issues. In the lower atmosphere where we live, nitrogen and oxygen come together to make nitrogen monoxide and nitrogen dioxide on their own. Primary place where this happens is in transportation. Things like buses, trains, automobiles, vehicles. What can happen is that these oxides, NOx gases for short, these NOx gases can interact with the oxygen in the air and create ground level ozone. Ground level ozone is a major pollutant. It's also kind of dangerous. It's not something that you want to breathe in a whole lot of. Ozone has kind of an odor to it. You can think of the odor of ozone as kind of, if you've ever kind of caught a whiff of what smells kind of metallic when you see electrical sparking, that's ozone. So that odor that comes from plug something into the wall and it sparks. That's the smell of ozone. In small doses, doesn't really do much to you. But if you're in a large city and there's lots of it being made, it can have a really nasty effect on your respiratory system. One of the reasons why, if you look at some of the industrialized parts of certain countries, it'll look like it's kind of in somewhat of a fog all the time, and the people there are wearing masks and other things. It's not just for health in terms of like infectious disease. It's because the air pollution is so bad, they need to filter it in some kind of way. So again, if we look at where most of these NOx gases come from, almost 85% of those gases come from transportation. So again, where we see this the most often are in crowded, populated areas. Here in Vincennes, we don't get as much of it, because even in our worst, heaviest traffic day, where we're all waiting for that 112-car train to cross over 6th Street, we don't have that many cars populated and congregated in one area at the same time. But if you go on a big part of like Los Angeles, or a really heavy traffic city like Chicago or New York, you're going to see this kind of problem crop up from time to time, especially in warmer summer months when that conversion to the NOx gases is going to be accelerated because it's warmer and we have larger amounts of ultraviolet light coming in from the sun. Other sources you can see about 1.5% coming from just the production of cement, 3.5% coming from the production of paper, and 10% coming from other areas. But the majority of it is transportation related. What do we know about inhaling NOx gases? Well, because they're gases, again, inhalation toxicity is the biggest culprit. NOx gases are readily absorbed into your bloodstream, and they are hemoglobin inhibitors. They interact with your hemoglobin to cause something called methemoglobin. And methemoglobin has the same kind of impact that we saw with carbon monoxide. It attaches to the hemoglobin much stronger than oxygen does, and therefore is very difficult to get off. How do we recognize it? Well, individuals that are exposed tend to have the initial symptoms of poisoning. They have a dizziness, they have a headache, which are common for a lot of those infectious kinds, or not infectious, a lot of those gas kinds of issues. We saw the same thing for carbon monoxide. We saw the same thing for the sulfide gases. Diarrhea and anemia are also signs of toxic intake. But the big thing, the one thing that we can really recognize with this particular group of people is the color of their blood. Their blood becomes a chocolate brown color because of the reaction of those nitrous gases with that hemoglobin. And the other thing that is important to know here is that unlike with carbon monoxide poisoning, where hypobaric oxygen therapy is the way to get it out of the system, it's not going to be very effective here if we're dealing with methemoglobin. So this is the place where a field diagnosis is going to do a lot of help in terms of trying to figure out the best course of treatment. You know, initially, yes, you're probably going to give them oxygen just because that's kind of what you do. But in terms of how therapeutic that is, no, the best course of action is to get the person to a hospital, get them to the proper treatment avenue. More problems. Nitrogen dioxide can react with the water in your system. And when it does, it produces a mixture of acids. The mixture of acids include HNO2, nitrous acid, and HNO3, nitric acid. The nitrous acid is not particularly fun to deal with. The nitric acid is actually one of your strong oxidizing acids. And so because of that, we're going to see a lot of damage to the lungs, to your connective tissues. We can also see pulmonary edema and some other kind of nasty health effects as a result as well. So these gases do carry a little bit of extra oomph when it comes to their reactivity and what they do to your body. All right, we have one more gaseous material to talk about, and it is a nitrogen product as well. It's ammonia. Now, we have talked about ammonia at different times throughout this semester. Ammonia, NH3, we have talked about it as being an irritant. We have talked about it as being flammable, but not classified as flammable. We've talked about it as a number of different things. Commercially, we know that ammonia is used for many different things. We can get it in the gas phase, although it's usually mixed with air or helium. Where we see it the most often is in this compressed form known as anhydrous ammonia. Again, this is the stuff that you see that gets sprayed into commercial farms as a nitrogen enhancer for the soil. We can also see it used as a coolant for refrigeration systems. Again, that's the anhydrous ammonia there as well. And as I mentioned, it is used as fertilizer. Again, in large commercial farms, it's usually that second form there. So what does ammonia do? Well, the primary thing that ammonia does is it's an irritant. Ammonia can interact with water vapor and become a basic solution. And that basic solution can have a really nasty effect in terms of irritating your eyes, your skin, your mouth, the parts of your respiratory system when it's exposed. You know, we did that whole business with corrosive materials. That was one of the things that we talked about with corrosives. Bases do have an effect on your body, on your skin, and the areas that are most susceptible are the ones that have the least protection, which would be things like your eyes, your mouth, things that have mucous membranes that aren't covered in skin. When we see concentrations greater than 2,000 parts per million, ammonia will cause death by suffocation. And there is a known condition caused by the high exposure to ammonia called hyperammonemia. And basically, it is a disorder caused by having too much ammonia in your blood. Now, how do we treat it? Pretty much the same way we've treated pretty much every other toxic kind of exposure. We get the person out of the scene. And one of the things that we do, since we are talking about a corrosive here, is we look to dilute it. So flushing the area with lots of water is going to reduce that irritating effect, reduce that corrosive effect, and obviously providing oxygen so that the high concentration of ammonia can get out of the respiratory system and the person can start to breathe normally again. Hyperammonemia is a life-threatening condition. So obviously, if we came into contact with that kind of a situation, we would be seeking medical care immediately. That's a automatic 911 call if that was something that you recognized was happening. What does it look like? Well, there's lots of things. Lots of ways that we can recognize that hyperammonemia is taking place. So for example, general conditions, hypothermia. The individual is not only feeling cold, but their core temperature is dropping below a certain level. On the muscular side, poor coordination, seizures, tremors, kind of unnecessary and unprovoked shaking, shortness of breath, lethargy, coma, combativeness. So obviously some of these effects here are more acute than others. Some of these are going to be definitely on the more chronic and latent kind of thing. You're not going to immediately notice someone's liver getting bigger or immediately notice that they are experiencing growth retardation. That's something that you can develop over a long period of time. But some of these, yeah, we could recognize some of these signs as kind of a pattern and certainly recognize them earlier than others. All right, we're going to turn our attention away from gas phase toxins and talk about some others. So let's talk about carcinogens. Carcinogens are substances, or in some cases, living things like viruses, microbes, that can cause cancer in living tissue. So we're either talking about chemicals, physical apparatus, virus, but they're in some way linked to the production and causes of cancer. Now, what's kind of scary about carcinogens in general is that there are some people who are automatically predisposed to having cancer just based upon who they are. There are genetic predispositions to cancer that are in your DNA, well, at least in some of your DNA. So just by your very nature, by who your parents were, by who their parents were, and on down the line, there are some people who are just naturally predisposed toward cancer of some kind. Rough statistics say that 1 out of every 2 men and 1 out of every 3 women will have some form of cancer in their lives. So that's kind of just baseline what happens. Carcinogens are what can help that production to accelerate. So how do we determine whether or not something is cancerous? What do we have to do? Well, again, it depends on what it is that we are talking about. We know that carcinogens will act with different potencies on different kinds of people and with different kinds of animals. If we're talking about something that is chemical or physical, toxicologists can expose laboratory animals to that substance and in varying doses to determine the overall effect on what those animals experience, how often they develop cancer. On the human side, an epidemiologist can look at historical accounts and say, okay, this particular substance caused cancer in 25% of laboratory rats at this concentration. Do we have examples of people with similar exposure and what their cancer rates were? And we can also investigate it by demographic. Okay, is this a condition? Is this a chemical that adversely affects one population over another? Does this affect men more than women? Does this affect Caucasians versus African Americans versus Asian Americans versus Pacific Islanders? Does this affect the young versus the old? So all sorts of demographic data can go in there as well. And epidemiologists look at it all and try to make approximations and eventually conclusions based upon those data. Now, in terms of cancer, there are multiple stages of development for cancer. There's the initiation stage. This is where your genetic material is altered for the first time, usually due to some kind of exposure to the carcinogenic agent. Once that exposure occurs and your genetic material has been permanently damaged, one of two things happens. Either the genetic material is so damaged that it basically dies and that's kind of the end of it, or the genetic material is damaged, but the cells are still able to replicate. And if it's the second here and the cells are able to replicate, then what we are in is the promotion stage. Promotion stage is where that damaged cell starts to divide and create more and more damaged cells. The third stage, progression. Now we're seeing that the damaged cells start to invade local organs. They start to invade tissues of healthy organs and cause them to become damaged as well. This is where we start to see the formation, in some cases, of tumors. And then the last part of this, kind of the special example, metastasis. When you hear someone has stage 4 cancer, this is what they're talking about. Whatever cancer was in one part of the body has caused it to spread to another part of the body. And now you have multiple systems that are damaged. You're starting to look at multi-system organ failures. You're looking at the potential end of someone's life. Now, ordinarily with carcinogenic materials, these are the kinds of things that develop over time. It is not usually one exposure, one time, cause this initiation stage to happen and the rest is history. Sometimes it is, depending on what it is that we are exposed to. If you're exposed to a high dose of radiation, then yes, one exposure might be all that you need. But the majority of things that we end up talking about and seeing have to do with long-term exposures. And again, you hear about them, watch TV for any length of time, you're going to hear a lawsuit ad about something. Talcum powder caused this kind of cancer. Working at this kind of industry caused this kind of cancer. Those are not one-time exposure things. You didn't use baby powder one time and develop stage 4 liver cancer. It took a while. Worked on you slowly. All right, let's talk about some other solid phase materials, like metals. Now, your body needs metal substances, metal ions, metal compounds for your basic work and survival. You need things like copper and manganese, calcium, iron. Those are all important for proper function of your body. And the multivitamin industry makes a living off of trying to supplement your diet with those things to help keep you functioning well. However, a lot of those metals are substances that if we have too much of them, they can actually give us toxic effects. They can either cause us to become ill, or they could cause us to die depending upon the concentration and the dose. Take iron, for example. Your body needs iron because, well, for many reasons, but let's talk mainly about your hemoglobin, which has iron at its center. Well, to make blood, to make new blood, you need fresh iron brought into your system periodically. Now, naturally, you retain, because we're all men in here, you retain more iron in your body because you don't have a menstrual cycle and lose a portion of your blood every month. So women naturally need more iron in their diets because they are losing more iron on a regular basis. And if you look at the differences between men's and women's multivitamins, that's one of the places you see differences. And if you accidentally take the wrong multivitamin, it can at least make you feel a little bit sick. Extra iron, too much iron, is actually bad for your body. Again, it comes down to the dosage. So let's talk about some metals where it's not just a matter of a mistake, but they're actually dangerous in their own right. Let's talk first about lead. Of all the toxic metals, the ones that we would classify as toxic based upon low doses of the substance, lead and mercury are the most common of the two. Where we will find lead primarily in our lives are in paints. Lead-based paint has been phased out. However, if you live in an older home, there is still lead-based paint probably in the windows and on some of the walls, depending upon how recently things have been painted over there. So where this comes in is if your house catches on fire and there's lead-based paint in it, the lead paint would form a dust that would show up in the smoke. And that would be one way that you could get the lead into your body. Probably the most vulnerable population for this kind of exposure are young children, because young children put everything in their mouth. And so if they happen to grab some paint chips that fell on the floor because they flaked off of your windowsill, that can be a way that they can get exposure to lead. Where lead is dangerous is lead actually works on your central nervous system. And chronic lead poisoning can actually lead to nervous system impairments, including things like loss of judgment, paralysis, and other kinds of brain-based issues. Now, lead used to be a lot more common in our consumer lives than it is now. Lead used to be something that was added to gasoline to boost its octane rating. Lead was in a lot of paint products because it created good, strong, stable pigments that did not fade over time. And so you would see not only latex paint, but things that would be made for painting children's toys would have lead in them. Over time, those things have been phased out. Consumer product safety boards come in, made it so that it's illegal to import toys that have lead-based paint in them, and certainly illegal to use it. Lead in gasoline was phased out somewhere in the 1980s. So lead exposure in children has some couple of really bad long-lasting effects. Impairs their ability to learn, impairs their ability to execute mental processes effectively, And this does not actually end. This is something that stays with the child all the way through adulthood. So it's not something that they even can grow out of. That damage to their central nervous system is pretty much permanent. In adults, we can also see there are a lot of systems that lead impacts. It impacts your ability to form new blood. It impacts your nervous system, as we already mentioned. It impacts your kidneys. It also can have harm to your reproductive, endocrine, hepatic, cardiovascular, immunologic, and gastrointestinal processes. So pretty much everywhere. So lead exposure is dangerous. It is banned with good reason, not just for children, but for adults as well. So this is one of the ones that has as close to a systemic whole body effect as anything would. As I mentioned, there are regulations on the use of lead. Basically, lead is illegal to use. You cannot have lead in any paint or surface coater. So no lacquers, no shellacs, no powder coatings, nothing with lead in it. Toys cannot bear lead-based paints. Companies that import children's products have to test that they do not contain a certain threshold of lead paint. And that is not only just a dosage rating, it is a maximum rating as well. So ideally, those numbers would be really close to zero. In practicality terms, that's just not really possible. And again, one of the things that we run into with lead is its cost. Lead-based paints are a lot cheaper than others, and so where we see this particular problem coming in is from overseas production, primarily China, as well as some of the other developing Pacific kinds of nations where we do a lot of our cheap goods importing, like Southeast Asia, Indonesia. These kinds of imports tend to be the most problematic. All right, another toxic solid material is asbestos. Asbestos is very well known as being related to cancer, although it is not necessarily full out a carcinogen. It's kind of it's a little bit. So asbestos is the generic name for a mineral compound that contains a large group of silicates. There were lots of uses for asbestos. We would find it in insulation. We would find it in fireproofing. We would find it in soundproofing. We would find it used decoratively. The primary reason for it and why it was so useful, it does a really great job of absorbing a lot of heat without raising its temperature very much. That's why it was used for those purposes. Put it around your venting in your home, your hot vents as they're cycling air through aren't going to cause the rest of your house to get hot. So you don't want the inside of your walls getting hot because your furnace is on. Homes and other kinds of buildings with people in them that were constructed anywhere up until about 1984 most likely have or had asbestos in them. Now, on its own, asbestos is not terribly dangerous. Where it has its danger is when it starts to break down and degrade. So the primary issue with asbestos is when it starts to break down, those silicates form these tiny little fibers, and those tiny little fibers can get into your lungs, get into your circulatory system, and cause all sorts of problems. We call them friable fibers. The most common place where we end up finding them is because they are kind of the byproduct of construction, the byproduct of certain types of metalwork, is lung cancer. The asbestos gets ground up or gets powdered or aerosolized in some kind of way. The construction workers or the plumbers, the pipe fitters, whoever they are, end up breathing that stuff in, and those little friable fibers get stuck in the lungs. And over time, those little fibers getting stuck in the lungs, that causes enough damage to actually cause cancer. And this is something we were able to prove over time as we were looking at different kinds of lung disease. We were able to look into and cut open some tumors, and we find those little fibers in there, and eventually start making the connection between the presence of those fibers and the presence of cancer. Now, there are two types of conditions that can be caused by exposure to asbestos. The first is called asbestosis. This is a scarring of your lung tissue, but it is not cancerous. Problem with it is irreversible. It's progressive, so it gets worse over time, and there really isn't a treatment for it. But that's not the one that we know the most commonly. The one we know the most commonly is mesothelioma, because this is the one that is the subject of all of the lawsuits. Mesothelioma is a cancer of those membranes around your chest, around your abdomen, around your internal organs. And mesothelioma can develop into something called pleural mesothelioma, which is a cancer of that protective lining around your lungs. So not the lung cancer itself, but the area around that lung tissue. And that particular form of cancer is fatal. And that's also why a good number of these lawsuits exist. Because when it comes to the loss of life related to something you were exposed to at work, people start to ask questions about whether or not the employer was responsible, or whether or not the people who manufactured the asbestos are responsible, or if anyone is held responsible. So in some ways, those lawsuits are somewhat of a money grab, but in a lot of ways, you're talking about people who lost somebody they love and are looking for some kind of tangible way of honoring them or of replacing the money that they lost because they died before retirement age, or any other list of reasons. So regarding asbestos, it's basically you can't use it anymore. If you do, there are very, very, very limited purposes and reasons for it. If you find asbestos in your home, you cannot just simply remove it. It has to be abated properly. However, if you find asbestos in your home, you are not under any obligation to remove it unless you're doing some kind of construction that would damage it. So, for example, there are a number of asbestos floor tiles out there. Unless you're planning on jackhammering your floor up to get those tiles out, yes, you'd have to go through abatement there. But probably just slap some plywood over them and do whatever you want underneath as well. That's just as okay. All right, we did not get to infectious pathogens or toxins. I will leave you to read this on your own. There's some good information in here about anthrax and ricin. I also have a video of it that I will attach to this one. So if you are interested, it's there. But that is the end of chapter 10 for us.